part 4 here. How do we protect our infrastructure, and how will the infrastructure protect itself, and how will we define these digital rights? So the biggest thing is we now consider users as users are part of the functional network. They're now part of the network itself. And that users have competing interests here, where the rights to privacy and the rights of control, and the solution is we break it into security, privacy, control, and accountability. And that every relationship in the system, and these relationships between businesses and users, will have competing interests. And we use these principles that we have discussed to manage these problems. The infrastructure protects itself with the security and accountability components, and the control and privacy is done through the privacy and control part of the infrastructure or management principle. Security is really responsible in seeing who is doing what. It's involved pretty much in everything. It tries to restrict the sharing of information. It tries to identify bad behavior. It identifies nodes, entities, and users inside the system for utilizing in other components. Privacy is determined by one relationship to another entity. Control impacts which rule and how a rule is implemented, and each party defines the privacy of the relationships, both for sending and receiving. And access is part of a relationship definition, so we explicitly will say who is allowed access to this information as part of a relationship. Control allows us to identify the users and associated elements of influence. Control defines what the operation are, such as functions and data rights. So control is the management of different types of entities, users, the entities, their devices, and all the relationship between them is defined within control. And the accountability ensures that all the rules and regulations within the system are followed. It's the mechanism for self-preservation of the system, and it includes limits for command and control elements to verify it. And all these processes are interlinked to each other. The principal interactions are for privacy for an owner and user is knowledge-based management. For control, it's defining for a user the relationships and operations. Accountability is bound settings. Security is for security, it is bounds enforcement for a user. For device entities, it's visibility on the system. Control defines access management and state management for a device. Accountability is behavior enforcement, as well as security is behavior enforcement. Information for privacy is the visibility of data. Control is entity assignment. Accountability of information is the integrity. And the security of information is who gets to see it again. So the infrastructure protection here allows for dynamic remote firewall rules, pathway management, and the bad request return systems. So how do we now protect against a distributed denial of service attack? We now have this attack start connecting up to a node. They send data through to a device, to multiple nodes, and eventually it hits the target node, which is here. This node can then respond back immediately saying that these are bad requests using the bad node request return, and this affects the relationship management process. We can now say that in this relationship management process that we are going to block these bad relationships further away from the node that is actually being targeted. How this messages could be passed even further, eventually isolating the bad nodes out of the system and affecting the relationships of node to the applicable nodes for all the nodes in the system so that the bad nodes are isolated out of the system, and this affects the long-term relationship management of these nodes to any other node in the system. This means now that the relationship management now knows about problems that are occurring, and we can now utilize that data to make the system protect itself. Now the same problem occurs for, let's say, an overload of a device or service, but because a node gets too busy, as seen here, we can respond with "I'm too busy, but these are valid message requests," and order the other devices to back off for times through the relationship management system. And we can put a wait time or simply say don't send messages for a time window, allowing this overload to be dealt with in a more efficient way. And we can see then the relationship management to say that these nodes stop sending data and that they now properly wait for their turn to send their attempt of data. This means that our overloaded data stream never stays in overloaded, and the infrastructure fixes itself automatically, and we're aware about it for the relationship management is where that this node is we're overloading and we're waiting for it. This accountability equals protection. These are simple solutions that provide complex protection, and our infrastructure protection is automatic, and accountability is a universal principle. The control of information in privacy is hard. This is a big issue. Where do we start? Privacy means we got to protect our information. Control means we have to give the owners of the information control. Accountability means that we have to have monitoring and consequences when stuff happens, and our security is required here for the privacy. So these entity relationship interactions here can get very complex in what's happening. Starting from a customer, they've got their policies and permissions. They go through a device which got policies and permissions, which connect to a legal entity, which connect to another legal entity's devices through more policies and permissions. And all of these systems in here talk about what doing. Relationship management is saying who, what, when, frequency, and what actions you're doing. Security management says who, the frequency of what you're doing, bad behavior, and whether or not this is a disposable ID for privacy. And our health system says what is the current things going on, and how do we test our backup in the system itself to know that the backup will work. And our support system is saying it documents our past problems and what we've done to fix them in the past. So looking towards a real example here, let's have a customer that is buying some apples. The customer is here. They're a legal entity and they want to buy some apples. Now, do they have a disposable ID, or do they have maybe, let's say, a convenience card which directly connects them to the apple seller? Either they use the disposable ID or they directly connect through identifying themselves to the Apple seller. There's privacy and permissions which change depending upon whether it's and then you know the person, whether you get the rebate for the apples because you're a convenience member, and then the passing of data from this Apple seller when they have to pass the tax on to the government or another entity. They have policies and permissions of what they can see into the Apple seller. So the principles of privacy, control, accountability, and security allow us to have sharing, transactions, and informations between systems and users. So now our message delivery. So looking back to TCP/IP, we have unknown author, unknown content, and unknown sender. And we've got to do all of our validation, and we have to review all of our messages ourselves, and we've got to establish our importance ourselves, and we've got to respond. The problem is we've got undeliverable, we've got junk messages, we've got dangerous messages, we've got malicious messages all being sent, and we don't know who sent them as a system. As well as the problem of when our message delivery box gets over full, we don't prioritize what's important to ourselves. So now when we have a secure relationship delivery thing, we know who sent it, we know who authored it, we now know how important this message is in the relationship, and we have knowing about when something failed. So we still got to review all the messages here, but we've done all of our validation for sender/relationship before we need to get into the application necessarily. We can now establish importance much easier, and we can respond as required. And we now have a linked process for dealing with all the issues of junk messages, dangerous messages, malicious messages, as well as dealing with message queuing when our message delivery is overfilled. This message delivery service here is designed to sort of guarantee delivery and ranking of our messages. This allows us to protect our infrastructure, our information, and people. In conclusion, our existing infrastructure cannot stop our attacks and information theft. We have to design a new network protocol which must include privacy for protecting information and operations, control for ensuring privacy and security to protect information and operate. Accountability must exist on all levels of operations, and security is fundamental to life. Mascroft's hierarchy of needs highlights the needs for security, safety and security.